All right, ladies and gentlemen, welcome back to Logic. In this video, I'm going to show you how to check the categorical syllogisms for validity yourself using the Venn diagram. Last video, we checked the categorical syllogism for validity by finding the form and then checking a list of valid forms to see if your specific form was on that list. But now you don't have to check the list. We can simply check it for ourselves using the Venn diagram. Now you may remember that I have a video about Venn diagrams, video number 55 in the playlist. Now that Venn diagram was used to test immediate inferences. That Venn diagram had 2 circles, but this Venn diagram will have 3 circles, and that's because the categorical syllogism has 3 terms. The diagram looks like this. Now these 2 are for the conclusion, the minor term and the major term. This circle is for the middle term. We label them M for middle term, S for the subject of the conclusion, which is the minor term, and P for the predicate of the conclusion, which is the major term. Now make sure to draw your circles large enough to draw in each section. Don't make them like this. Make them like this. Let's check this syllogism for validity, and the first thing you do is enter the information from the premises into the diagram. Then you check the diagram to see if it supports the conclusion. We go from premises to diagram, then diagram to conclusion. If the diagram does support the conclusion, then the syllogism is valid. Let's enter the information from the premises into the diagram. When you look at the premises, which premise do you enter first? Well, universal premises always get entered first, and then the particular premises. Now, since both premises are universal in this syllogism, it doesn't matter which premise you enter first. Let's enter the major premise. Now, since it concerns the P and M circles, we focus only on those circles. Now, the premise says that no P are M. Nothing in the P circle is in the M circle, so we shade this area where the 2 circles overlap. Shading means that this area is empty. The first premise is entered. Next, premise 2, the minor premise. This premise concerns the S and M circles, so we only focus on these 2 circles. The second premise says that all S are M. That means everything in the S circle is also inside the M circle, so you will shade this area, which pushes all the members of S into the M circle. Now the diagram is complete. You do not diagram the conclusion. You just look to see if the diagram supports the conclusion. Now the conclusion will always be about the S and P circles, so we focus on these 2 circles. The conclusion asserts that no S or P. Look at the diagram. Does the diagram show that there is nothing in the S circle that is also in the P circle? Does the area where the S and P circles overlap contain anything, or is it empty? That's correct, the overlap area is empty. Since the diagram matches the conclusion, is the syllogism valid or invalid? 3, 2, 1. Ding! It's valid. Now you can do this by yourself. Just remember, premise to diagram, diagram to conclusion, and universal premises are entered first, 3 circles for 3 terms. Now for this syllogism, what do you do to diagram the first premise? Press pause if you need to. The answer will appear in 3, 2, 1. Ding! You must shade an area. Now what area must be shaded? The answer will appear in 3, 2, 1. Ding! These areas are to be shaded. What must you do to diagram the minor premise? Press pause if you need to. The answer will appear in 3, 2, 1. Ding! you must shade an area. And what area must be shaded? The answer in 3, 2, 1. Ding! These areas are to be shaded. Congratulations! The syllogism is now diagrammed. Now, does the diagram support the conclusion? Press pause if you need to. The answer will appear in 3, 2, 1. Ding! Yes. Now, since the diagram does support the conclusion, is the syllogism valid? Press pause if you need to. The answer in 3, 2, 1. Ding! The syllogism is valid because the diagram supports the conclusion. Now, here's an example of an invalid syllogism. When you diagram the premises, the diagram looks like this. And when you look at the diagram to see if it supports the conclusion, you will notice that this area is not shaded. But the conclusion says that no S or P. Since the diagram shows that a member of S could be here within the P circle, the diagram does not support the conclusion, and therefore the syllogism is invalid. Okay, let's look at a syllogism that has a particular premise. We always enter the universal premise first. We diagram it like this. Next, we diagram the particular premise. But how do you diagram this premise? Well, the premise says that something exists where the P and M circles overlap. Since this area is already shaded, we place an X here. We use an X to represent existence. Since both premises are diagrammed, we check the diagram to see if it supports the conclusion. Well, does the diagram support the conclusion? Press pause if you need to. The answer in 3, 2, 1. Ding! Yes. There's an X in the overlap area. Just like the conclusion claims, the syllogism is valid. Now here's an interesting syllogism. First, we diagram the universal premise, then the particular premise. Then we check the diagram to see if it supports the conclusion. Notice the conclusion claims that some S are P. The diagram shows that S could be P, but it doesn't prove that some S are P, because there is no X in the overlap area. So the syllogism is invalid. This next syllogism is a bit different. First we diagram the universal premise. Then we diagram the other premise. But how do you diagram this premise? Does the X go here or here? Well, what you do is, since you don't know where it goes, you put the X in the middle. This means that something exists either here or both places. Now check the diagram. Does it support the conclusion? The answer is no. The conclusion claims that some S are P, but the diagram is not conclusive. After all, the X could be here, so the syllogism is invalid. Anytime an X is placed in the middle of the line, the syllogism is always invalid. Next, we'll work 5 quick practice problems, then move to the next topic, which is about drawing missing conclusions. Now, on these practice problems, I recommend working them on scratch paper and really participate to get your experience. Now, when I give you the answer, I'll also show you the correct diagram. So practice problem number 1. Is this syllogism valid or invalid? Press pause if you need to. The answer will appear in 3, 2, 1. Ding! The syllogism is invalid. See the diagram? Next practice problem. Is this syllogism valid or invalid? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The syllogism is valid. Next practice problem. Is this syllogism valid or invalid? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The syllogism is invalid. Next practice problem. Is this syllogism valid or invalid? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The syllogism is invalid. Final practice problem. Is this syllogism valid or invalid? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The syllogism is valid. Very good job on those practice problems. Next, we'll use the Venn diagram to draw missing conclusions. This is how you'll do it. First, enter the premises into the diagram, then look at the bottom two circles. What conclusions can you draw from this diagram? Well, you can see that there's an X here, which is outside of the P circle, so you know that some S are not P. And this is the missing conclusion. Here's another example. First diagram the premises, and notice that there's an X on the line. This means no conclusion follows from the premises. Remember, there are only 4 possible conclusions: the A, E, I, or O propositions. If you're having trouble, just think about all 4 of the propositions to see if they fit. If the diagram does not support any of these conclusions, then the premises do not imply any conclusion. All right, let's work 5 quick practice problems, and then you will have completed this section. Practice problem number 1. What conclusion does the diagram support? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The missing conclusion is no S or P. Next practice problem. What conclusion does this diagram support? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! No conclusion follows. Anytime an X is on the line, no conclusion follows. Next practice problem. What conclusion does this diagram support? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! No conclusion follows, since the X is completely outside of the S and P circles. Final practice problem. What conclusion does this diagram support? Press pause if you need more time. The answer will appear in 3, 2, 1. Ding! The conclusion that follows is some S are not P. And very good job on those practice problems. Give yourself a big round of applause. You are now one step closer to advancing to the next level. See my other videos on logic. Comment, like, share, and subscribe. And have a great day.